Today on How It's Made. Condoms. With this item, we bring you the long and the short of it. Classic car gauges. Posh clocks for old crocs. Chocolate marble truffle cake. We dig our noses in to turf up the facts. And gilly kettles. Take it from us, these are terrific. But first, throughout the ages, men have used condoms made of an amazing variety of materials, from simple cloth and oiled paper to tortoise shells and animal horns, though don't ask me how. Anyway, thankfully today we can stay safe without having to don dead animal parts. The rubber condom was invented in the mid-19th century. Today most are made of natural latex rubber, which is strong, thin and longer lasting. Apart from being strong, modern-day condoms must be comfortable. The factory begins by mixing liquid latex rubber with stabilizers, chemical strengtheners, antioxidants and accelerators to speed up the curing time. Glass condom molds travel in single file along a dip line. The first station washes them with water and dries them with a spinning brush. The molds then move onto the second station, where they're dipped into a latex-filled tank. The temperature of the latex is maintained at 25 degrees Celsius to prevent it from evaporating, creaming and destabilizing. The molds spin through a dryer, are dipped again, then spin through the dryer once more. The latex is now the correct thickness. The next station on the line curls up the edge with a rolling brush, forming what's called a bead. This bead is what later enables the condom to be rolled up into a flat disc. The condoms go through an oven for 10 to 12 minutes. When they come out, the latex is cured. The next station removes the condoms from the molds with high-pressure water jets. They're now washed and dried with a cornstarch solution. This leaves a layer of powder on the sticky latex surface, preventing the condom from sticking to itself. The factory's quality control lab checks random samples from every batch. In this test for tensile strength, they cut a ring from the cross-section of a condom and stretch it, measuring how much force it can withstand before breaking. This test inflates the condom until it bursts and measures the amount of air volume and pressure just before rupture. Then there's a water leakage test. They fill the condom with water and hang it for a prescribed length of time. Then, applying pressure, they roll it on an absorbent paper to check for a water spot, evidence of a microscopic leak. Every single condom the factory makes, not just test samples, undergo an automated inspection for holes. This machine picks up and opens the condom and loads it onto a mandrel. The mandrel is made of metal, a good conductor of electricity. A spinning rubber wand with an electric current running through it goes over each condom. If there's a hole in the latex, the current from the rubber wand will run through it and come into contact with the mandrel. This triggers the machine to reject the defective condom after it's rolled up. The condoms roll up neatly thanks to the bead at the rim. A robotic arm tosses the defective ones into a rejection bin and places the ones that passed hole inspection on a conveyor belt that takes them to the collection bowl feeding the packaging line. A sensor counts the condoms as they move towards the packaging machine. The machine squirts lubricant on each condom before inserting it between two sheets of foil composed of aluminium and plastic. A heat sealer seams the four sides to form a packet, encasing the lubricated condom. The machine's guillotine then cuts strips of a specific number of packets. At the next station, robotic arms fold retail boxes and place them on the line, the open end facing the arriving condom strips. Pushers insert them into the box. The next station seals the boxes and prints the lot tracking number and expiry date, both of which were also printed on the foil packets inside. The foil packets protect the latex from damage caused by moisture, heat and ozone, so these condoms are good to go for the next 5 years.